Hi, welcome everyone to the video lecture on VLSI design and testing. So today's topic for the video lecture is MOSFET. So in order to understand the further lectures of VLSI design and testing, let's start with the basics of understanding of what is a MOSFET, what are the classification of a MOSFET, how MOSFET is operated, what are the different terminals that are there in a MOSFET. Since the VLSI chips are fabricated using a MOS transistors, so it is very important to understand what is a MOSFET. So let's begin. Here is the definition of a MOSFET. So what is a MOSFET? What is the abbreviation of a MOSFET and what type of device it is, how many terminals it is having? So let's start discussing on this. So here MOSFET is a metal oxide semiconductor field effect transistor, which is electronic device which is used to switch or amplify voltages in the circuits. It is a voltage control device and it is having 4 terminals. The terminals of the MOSFET are source, gate, drain and body. So when it comes to BJT, bipolar junction transistor, it is having 3 terminals which are called as emitter, collector and base, and BJT is called a current control device and MOSFET is a voltage control device. Next, what are the MOSFET types? So there are basically 2 types of metal oxide semiconductor. One is called as N-channel MOSFET and another is called as a P-channel MOSFET. So when you say NMOS, the majority carriers are electrons, and when it is PMOS, the majority carriers are holes. Also, this MOSFET can be classified as the enhancement mode and depletion mode. In enhancement mode, again they can be classified as the P channel and N channel, and depletion mode transistors the P channel and N channel. So here when we say MOS transistor, it is a majority carrier device. So what is a majority carrier device? When you say NMOS transistor, the majority carriers are electrons, and PMOS transistors, the majority carriers are holes. So this diagrams are showing you the MOS transistor symbols. So the first here is the N channel or NMOS transistor, and this is also NMOS transistor which is showing the the current flow, and here the below is the PMOS transistor. So next, this is a construction of a MOSFET, or we can also call it as a cross section of a MOSFET, which is showing us the NMOS transistor. So the P-type semiconductor, in order to construct an NMOS transistor, the substrate will be P-type and the source and drain diffusions will be of N-type. So here it is named as the N plus diffusions or N plus base, which are highly doped. N plus indicates they are the highly doped with an N-type impurity, which is marked as the N plus. And in order to form the heavily doped regions of the base, the terminal, source and drain will originate. And the layer of the substrate will be also having with a layer of silicon dioxide. So this substrate will be separated from the gate with the help of silicon dioxide, which is acting as an insulating material between these 2 layers. A thin insulated metallic plate is kept on the top of a silicon dioxide, and it is also called as a capacitor. And the gate terminal is brought out from the thin metallic plate. The DC circuit is then formed by connecting a voltage source between these 2 N-type regions. Now, what is the working principle of a MOSFET? The working principle of the MOSFET will depend on the voltage which is applied to the gate. When a voltage is applied to the gate, an electrical field is generated that will change the width of the channel. Here the channel will be created that will change the width of a channel region where the electron starts flowing. So we can say wider the channel region, the better conductivity of the device will be. Next, classification of MOSFET as discussed in the previous slide. It is either depletion mode or enhancement mode. So what do you mean by depletion mode transistor is, depletion mode of MOSFET is, when there is no voltage across the gate terminal, the channel shows a maximum conductance. That means with Vg is equal to 0, that is the gate terminal, even if you apply your no voltage, Vg is equal to 0, there will be a channel created which will show the maximum conductance. And in order to remove this channel, so there should be the channel, in order to decrease the channel conductivity, so gate terminal should be either positive or negative. Or simply we can tell the depletion mode MOSFET is a MOSFET where the channel will be already formed during the fabrication with the help of implantation process. An enhancement mode transistor, when there is no voltage across the gate terminal, then the device does not conduct. That means with Vg is equal to 0. The input voltage is 0. There is no, the transistor does not conduct. And when there is maximum voltage across the gate terminal, then the device shows the enhanced conductivity. So depletion mode MOSFET, Vg is equal to 0. That is, there will be a channel and there will be a current flow, and the transistor is said to be in on condition. But when it comes to the enhancement mode transistor, enhancement mode MOSFET, the gate terminal, Vg is equal to 0, transistor is off. When Vg is equal to some voltage is applied, then there will be a conductivity in the channel. Thank you.